Hello and welcome. This is the introduction to our end of semester college project. This is our team. My name is Dimas Rai Fariski with the last three digit name is 705.
My name is Diandra Trinita Visa and my three last digit name is 070.
My name is Bindar Mata Putra. My last three digit is 101.
My name is Hanifa Kunafa Izam. My last registered name is 124.
And this is our end of semester college assignment, of which is to create a network of computer, router and server with a backdrop of an airport network. Hope you all enjoy this show. So when it comes to topology, there's topology design being used inside of this design. And those were star topology and ring topology. First off, the ring topology design used on the router network. The router network is shaped like ring. It has the advantage of minimum data coalition and cheaper to install compared to star topology. The issues come when one router down in an error, everything is coming down along with them. Not just one computer, not just one computer error. Any error is a big tragedy. Also, adding and removing device might not be the most convenient thing ever, but still for the minimum coalition, we take this design for the routers. Second, and also the last design being used is star topology. We use those on almost every part of the design. Even when it doesn't seem obviously, it has a couple of effectiveness such as it's easy to set up, it's easy to notice an issue and isolate those issues, and it's cheap. But those come with the disadvantage that if the main hub fails, every single connection also fails. And despite the cost of maintenance, it's cheap. The cost of installation, on the other hand, is quite the buck of sacrifice. Despite that, the advantages is still plentiful, and that's why we use them. Next.
Structure explanation. For the general structure of how we separated the computer, we split them into group of four into five different rooms. Starting from the front and going counterclockwise, we have the customer service room with red. We envision this as the room that handle all of the information that customer would want, like flight information and management and such, along with their documentation for future use. Next up, we have the check-in station with orange. This is the row of computers that are used for customer check-in, language management, and also a place to ask special requests for the flight, like say peanut allergy request to contain all the onboard peanut from being open.
Okay, and next up we have yellow. For yellow, we have also security that does security things like metal detector, criminal database checks, etc. Next up, uh, we have the green box for boarding, which is self-explanatory. Checks for all the information on boarding passengers and the luggage being carried. And lastly, for the last human working room is the admin's room with baby blue. It uses its uses is to manage and administering all operation of the airport device and supporting all of this operation.
Lastly, the two unique room with the router network and the server room which both are self-explanatory. Router is what makes all of those devices to be able to connect to one another, and server room is what holds all of the data for all of the airport operation and coordinating those data to other computers so that they will get the memos. And here we can see the IP address for all of the devices. For all of the computer in uses, we use the C-class public IP address with the 29 subnet mask since it filled the requirement without going to overboard on empty host. The only difference is the third octet filled with continuous number from 1 to 5 on a counterclockwise direction.
And for the router IP address, here they have the following convention of multiples of 10 three times going counterclockwise, just like the rest of the project, with the last order represent which router are they belong to and a subnet mask of 24. Lastly, for the server, it's a multitude of 13 and 23, and there is little to rhyme or reason, honestly, that to be the case. And that's it. Transition to the ground test.
So the next is the test drive.
Okay, here we can see the project. Let's test a couple of simple PDF send. Firstly, we can try to go from check-in station 1 through check-in station 4 to try in between switch, see if it works. And we can see them. And as we can see, it's successful in between switch. Next up, for in between the same router. So let's try to go from security 2 to porting 3.
Security,
Yeah,
2%.
try that in progress. We can fast forward it.
Wait.
Oh. See, it worked. In between router, it worked. Next up, for the experiment between a different router, let's try to go from admin 3 to CS2. I don't know, just one. An issue. And see, it worked out in the end after a couple of trial and error. Next up, from PC to server, we could try a security PC towards server A.
And okay.
Oh, if I can. And it's successful to the very end. Next and lastly, we can try to go from server to a PC. So let's try to go from server P to porting 2.
Server 2.
P to porting 2. Porting 1 also. That happened. Okay, and we can see all the project and like all the PDF send were successful despite a couple of bugs, but we can ignore that. And that's it for our test drive. Go back to our closing presentation.
That was the end of our little journey across this hypothetical airport. Hope you all enjoyed this little journey and see you all later. Goodbye.